Alright, welcome to Chemistry Video 3.4 here, looking at the law of conservation of mass. Kind of a big idea in chemistry. Let's make sure we get this one down here. So the objective here, understand or apply the law of conservation of mass to chemical reactions. Turn off your distractions, pause, rewind when you need to, and take some extra notes in the margins should you need to. Here we go! The law of conservation of mass states the following. Mass is neither created nor destroyed during a chemical reaction, it is conserved. What that means is, whatever the mass of your reactants are, that must be the mass of your products. Okay? You don't lose anything, you don't get any more stuff. The mass you start with is the mass you end with in a chemical reaction. Good example here. We got the 36 grams of water on this side, and you have a certain mass over here as well on the other side. I think it's a practice problem here. So how does this particular example here show us the law of conservation of mass? Well, remember back to physical science that here's your arrow. So basically the left side of the reaction is the reactants. The right side of the arrow is the products. And you can see we have 36 grams of reactant to start with, and we've produced 36 grams of products to end with. So you don't create any new matter or destroy the matter you do have. You keep the matter you have from start to finish. So which substances are the reactants? Go ahead and enter all these answers really quick into Edpuzzle. Okay, so which substances are the reactants? Well, reactants are on the left-hand side there. You start with the reactants; they react together. So our only reactant is H2O, which is water, and they are found on the left side of the equation. The products are on the right-hand side of the equation, and you have H2 and you have O2 as your products, and we find them again on the the right side of the reaction. Okay, so some little review of regular physical science. Here's a practice problem. Have you guys do this one as well and enter your answer into Edpuzzle. Read it carefully and see how you do here. This one's really just about reading carefully. Go. Okay, so it says when 10 grams of mercury 2 oxide is heated, the mass decreases. So I'm going to just write the 10.0 grams here. You'll notice we'll do this later this year when we do reactions. Underneath your substances, write down what you have. We have 10 grams of mercury 2 oxide. It's heated. Pure mercury remains, and it weighs 9.26 grams. Here's your following word equation. What accounts for the mass loss? So how do you go from 10 grams to only having 9.26 grams left over? Well, that's because the remaining mass here is due to the oxygen. When you produce oxygen in a reaction, if you can't trap it, it's going to go into the atmosphere and you lose it. So it seems like the mass has been lost, but really that mass that was lost is now in the atmosphere with oxygen. Now find the massless material. Well, it's pretty simple. Here's our arrow, so here's the product side. Sorry, here's the reaction side, here's the product side. Both sides must add up. So this missing X amount right here of mass of oxygen, let's solve for that. So it's 10 grams equals 9.26 grams plus X. And we'll subtract 9.26 from both sides. We end up with an answer of 0.74. 0.74 grams is the mass of the oxygen we had lost there. Alright, so again, law of conservation of mass states that mass is neither created nor destroyed during a chemical reaction. It's conserved, so the starting mass, 10 grams, must be equal to the ending mass, 10 grams, in a chemical reaction. Alright, good job.